Hey, Algebra 2, we have a little bit of absolute value stuff going on today. So let's go ahead and take a look at AVEI1, which is solving absolute value equations. We also got to create some stuff in there too. But let's take a look. Let's kind of go back to what a reminder of absolute value is. Remember that the absolute value of a number is the distance that that number is from zero. It's just a distance measure. It's not a direction measure. That's why we're going to take away the negative sign. It's just a distance measure. So I've got this, we're not going to graph this solution set, but I'm going to look at this here. It says we've got the absolute value of x equals 5. What numbers are 5 units from 0? Well, we know 5 is 5 units from 0, but what else? So I went, this direction is 5. I got to 5 units. But if I go this way, 1, 2, 3, 4, -5 is also 5 units away from 0. So I've got +5 and -5. So my solution set is x equals -5 or x equals 5. We got 2 solutions when that value is positive. We'll go through a few more of these things and take a look. Look at number 2. It says x equals, or the absolute value of x equals 5/7. In other words, I can have 2 different things. I could have x equals -5/7, or I could have x equals 5/7. Either one of those would make this thing true. Well, let's make things a little bit more complicated here, like we like to do. Now we have the absolute value of x minus 2 equals 4. We're trying to find the values of x where x minus 2 is 4 units away from 0. In other words, where x minus 2 is -4, or when x minus 2 is +4. I'm going to solve these independently. When I do that, I'm going to add 2 to both sides on this one. I get x equals -2, or add 2 here, x equals 6. That's my solution set, okay? Knowing these things that we've just talked about, go ahead and try numbers 4 and 5. Okay, now that we're back, same thing. We're trying to find the distance where x plus 3, the absolute value of x plus 3. So the distance where x plus 3 is 5 units away from 0. In other words, where x plus 3 equals -5, or where x plus 3 equals +5. Solve them independently. Subtract 3 both sides on this one. X equals -8. Or subtract 3 here. X equals 2. There we go. Same steps for the next one. We're trying to find out where 5x minus 2 is equal to -8, or where 5x minus 2 is equal to +8. Solve them independently. If I add 2, I get 5x is equal to -6. Divide both sides by 5. X equals -6/5. Or add 2 to both sides. 5x equals 10, divide by 5, and x equals 2. So the 2 solutions that make this one are x equals -6/5 or x equals 2. We can check those by plugging those values back in. If you plug those values back in, let's do this one actually. Let's do number 4. If I plug -8 back in, -8 plus 3 is -5, and the absolute value of -5 is 5. If I plug 2 in, 2 plus 3 is 5, and the absolute value of 5 is 5. You can always check your answers. Here's something here. In the last target, in CFR 4, when we're talking about, or CFR 3 and 4, we're talking about kind of, the graphing stuff. We said, treat it kind of like parentheses. And this is where the kind of like comes in, because they're not exactly parentheses. You cannot distribute through an absolute value sign. So let's check this, okay? Is -5 times 3 plus 7 equivalent to the absolute value of -5 times 3 plus -5 times 7? In other words, if I would have distributed through. Let's check that. This one right here becomes -5 times the absolute value of 10 which is negative 5 times 10, which happens to be negative 50. On the right, we would have the absolute value of negative 15 plus negative 35. Well, this is the absolute value of negative 50, and the absolute value of negative 50 is a positive 50. Whoops, just a positive 50. These do not equal. You cannot use distribution through an absolute value symbol. Okay, knowing that, let's go ahead and move to the next part. How to solve absolute value equations. We've got just a couple steps in here. The first thing that you need to do is isolate. Isolate the absolute value expression to the form ax plus b in the absolute value symbols equals c. In other words, the absolute value of something equals a number. The absolute value of something equals a number. And in the form that we've done it here, it's ax plus b in the absolute value equals c. So we need to write two equations. Ax plus b equals negative c, or ax plus b equals positive c. Then we would solve each equation independently. The first thing, though, is isolate. We need to have it, so we just have the absolute value of stuff on one side of the equal sign and just a number on the other. We're going to solve it just like we would do a two-step equation. If there are two steps, we'll see. I have negative 4 times 3x plus 1 and add the absolute value symbols. Minus 3 equals negative 11. I'm going to do the same thing I always do. I'm going to add 3 to both sides. I have negative 4 times the absolute value of 3x plus 1 equals negative 8. I'm going to divide both sides by negative 4. And I have the absolute value, because this is 1, right? Negative 4 divided by negative 4 is 1. So I have the absolute value of 3x plus 1 is equal to positive 2, because negative 8 divided by negative 4 is 2. I have isolated. That was step 1. I've isolated to get my absolute value equal to a number. Now I need to solve. So in other words, 3x plus 1 could equal negative 2, or 3x plus 1 could equal positive 2. And if I do that, I could subtract 1. I get 3x equals negative 3. Divide both sides by 3, so I'd have x equals negative 1. Or if I subtracted 1 here, this is 3x equals 1. Divide both sides by 3, x equals 1/3. Try that again. Try that again. Okay. That is how you take care of those. It's the same thing as if, let's just before we go on here, what if I would have solved and said negative 4 x minus 3 equals negative 11. Well, you would have told me add 3 to both sides, so negative 4x equals negative 8. Divide by negative 4, x equals 2. But it's not x, right? It's the absolute value of the stuff. It's the same concept, though. It's the same concept, right? Let's try, or actually, you need to try number 7. Hopefully you paused and tried number 7. If you haven't paused now, try number 7. Welcome back. Welcome back. I've got 2 times the absolute value of 4x minus 3 and the absolute value plus 5 equals 7. I'm going to do the same thing I always do. I would subtract 5 first from both sides of the equal sign. 2 times the absolute value of 4x minus 3 equals 2. I'm going to divide both sides of the equal sign by 2, because if I do that, that simplifies to 1, or 1 times 4x minus 3 in the absolute value, or just the absolute value of 4x minus 3 equals 1. And there we go. Go the same way. So I could have one of two things. I could say 4x minus 3 equals negative 1, or let's try this one a little further away. 4x minus 3 equals positive 1. So 4x could equal 2, or this makes x equals to half, or 4x minus 3 equals, I'm sorry, 4x equals 4 and x equals 1. There we go. There we go. One other thing we need to think about here. One other thing to think about. The absolute value of a number is never negative. So when an absolute value expression equals a negative number, there are no solutions. Makes it kind of nice. All right, we got a couple examples we're going to try. I'm not saying both of these are no solutions, but let's try them real quick. I have negative 3 times absolute value of x minus 4 equals negative 21. I need to start out by isolating, divide by negative 3. I have the absolute value, this simplifies to 1, or just the absolute value of x minus 4 equals positive 7, because a negative divided by a negative is a positive. And we can do this because that absolute value equals a positive number. So I could have one of two things. I could have x minus 4 equals negative 7, or x minus 4 equals positive 7. Start with the one on the left. I add 4 to both sides. X equals negative 3, or add 4 to both sides. X equals 11. Well, if this example didn't have it, I'm sure the next one will, right? Let's double check it. I have negative 6 times the absolute value of x plus 1 equals 12. Start out here by dividing both sides by negative 6, and I'd have the absolute value of x plus 1 equals negative 2. We've done that step one, right? We've isolated. It's the absolute value equals a number. If that number happens to be negative, I cannot take an absolute value and get a negative number. After you've isolated, if you get a negative number, this is no solution. No solution. There is a possibility you could have one solution too. If that you isolate, you get the absolute value equals 0, then you're only gonna have one solution, because you can't have positive and negative 0. It's just the same thing. Just the same thing. All right, let's look at a 3-level example. According to NFL rules, a football used in a game must have an air pressure within half PSI of 13 PSI. Tom Brady. Write an absolute value equation to model the situation and determine the least and most air pressure that the ball can legally contain. Tom Brady. All right. So let's do this thing. What I'm going to do is set it up this way. The absolute value of x minus a number equals something. And I'm thinking of this variation. We already know, here's the deal. We already know that this is 12.5 PSI and 13.5 PSI. But you got to prove it to me using an absolute value equation. Okay. And here's how I do this one. I'm going to take the number that's the variation, the number that could go added to or number that could be subtracted from. That's that half. I'm going to put that value right here. I'm going to put that value on there. I'm going to call this the variation. And on the inside, I'm going to take and make this the actual value. And that actual value in this case is 13. Okay. So the absolute value of x minus 13 equals half. So I've modeled it using an absolute value equation. Now I need to solve it. So in this case, I would have x minus 13 equals negative half, or x minus 13 equals positive half. If I add 13 to both sides here, I have x equals 13.5 PSI, just like we said, or, oh, that's 12, sorry, 12.5, like I said, 12.5, because you'd be subtracting, or add 13, x equals 13.5 PSI, Tom Brady. There we go. Now this setup works a lot. X minus the actual value equals the variation. Because that number that's the variation, that's what you attach the plus or minus to. That's what you attach the plus or minus to. And if you want to add something to both sides, it's x minus the number. That's how you set those up and solve them each time. That's it. That's it. Hope you guys are well. Take care. That's AVEI1 guided notes.